educational satellite television programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the extraction, properties, and uses of calcium. In our last lesson, we learned about the extraction, properties, and uses of sodium. We learned that this reactive, silvery white metal is manufactured using the Downs cell. During the process, sodium forms at the cathode of the cell and floats to the surface. This is because of its low density. We also learned about some of the chemical properties and uses of sodium, such as making sodium-lead alloy. In today's lesson, we are going to describe the manufacturing process of calcium. We will also explain the chemical properties of calcium and discuss some of its common uses. If you are ready, students, let us get started. Calcium is a soft, gray, alkaline earth metal. It is the third most abundant metal in the Earth's crust, of which it comprises about 4.7%, which you may remember from previous lessons. Calcium has a density of 1.55 grams per centimeter cubed, a melting point of 842 degrees Celsius, and a boiling point of 1,484 degrees Celsius. Some of the main ores of calcium include limestone, chalk, marble, dolomite, gypsum, fluorite, and hydroxylapatite. In Ethiopia, gypsum deposits can be found in the Danakil Depression. I'm sure you know that the Danakil Depression is a geological depression located in the Horn of Africa. It overlaps Eritrea, the Afar region of Ethiopia, and Djibouti. There are two methods that can be used to extract calcium. The first is by the electrolysis of molten calcium chloride. The oxidation, reduction, and overall reaction of this method looks like this. Calcium can also be prepared by the reduction of calcium oxide by aluminium in a vacuum. In this process, the calcium that is produced is distilled off. Students, let us do an exercise. Please list the common ores that calcium is extracted from.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. You were correct to say that some common ores of calcium are limestone, dolomite, and gypsum. If you said that chalk, marble, fluorite, and hydroxyl apatite are common ores of calcium, then you are also correct. Great work, students. Let us continue our lesson by learning about some of the chemical properties of calcium. Calcium reacts very well with cold water. During this reaction, hydrogen gas is liberated and calcium hydroxide forms. When calcium reacts with oxygen, calcium oxide forms. Calcium also reacts with nitrogen at very high temperatures. This reaction produces calcium nitride. Calcium reacts with certain halogens. It reacts with fluorine, chlorine, bromine, and iodine to form calcium fluoride, calcium chloride, calcium bromide, and calcium iodide, respectively. Calcium also reacts with hydrogen to form calcium hydride, which is a powdered chemical compound that reacts vigorously with water. In this video, you can see some people making calcium phosphate. In order to do this, they first pan-fried about 2 kilograms of eggshells until they were brown. As you can see in this video, they then poured vinegar into a container and slowly add the eggshells. The vinegar and the shells bubble and react. Once the mixture stops bubbling, they will have to cover the container and let it ferment for about 20 days. Then they will filter out the shells and they will have produced a container of calcium phosphate. It can be used in baking as a rising agent, in a variety of dental products, or to create certain fertilizers. Students, let us do an activity regarding the chemical properties of calcium. When calcium is exposed to air, it first forms calcium oxide. The calcium oxide is then converted to calcium hydroxide, and finally to calcium carbonate. Write a balanced chemical equation for each of these steps.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, everyone. Were you able to write balanced chemical equations for each step of the reactions of calcium? The 3 steps look like this. In step 1, calcium reacts with oxygen to form calcium oxide. In step 2, the calcium oxide reacts with water to form calcium hydroxide. In the 3rd step, calcium hydroxide and carbon dioxide react to form calcium carbonate and water. Please check your answers to make sure they are correct. If you had any trouble with this activity, please ask your teacher for assistance at the end of the lesson. Calcium is a very important part of living matter. By mass, it is the most abundant metal found in many animals, including humans. It is a major component of teeth and bones. When calcium is consumed early in life, it helps to build lifelong bone and teeth density. Calcium also plays a role in several metabolic processes. For example, calcium affects the functioning of the heart, muscle contractions, and nerve impulse transition. In today's lesson, we learned about the production of calcium, both by the electrolysis of molten calcium chloride and by the reduction of calcium oxide by aluminium in a vacuum. We also learned about some of the chemical characteristics of calcium, and that it is important to include calcium in our diets because it plays a vital role in different systems within our bodies. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.